My name is David Glynn. I work for Dell Storage in the VMware virtualization space. And this with me is George Jon, one of our Dell Premier partners who resells a lot of Dell gear but has been playing around with VVols for the past few months and has some good feedback. And I think the word we use is opportunities for improvement for ourselves and the industry in the space. So Jon will be coming up later on to discuss some use cases that they feel apply to their business, which was based on e-discovery. I assume that nobody here in the room is doing e-discovery, but a lot of those use cases also apply to your standard businesses in terms of how they can benefit you. Disclaimer, the usual disclaimer, some of the stuff we're going to talk about is future-ish and may not occur. That's what happens with futures. Sometimes they get canceled or moved on. So the agenda. This is a very free-flowing. There's a lot of give and take on some of this stuff. I hope to probably not going to have the live demo at the end, just because I know the Q&A last year when we had this VVols session ran very long, and I would first spend time on Q&A, then showing you guys how to create a storage container. If you want to get hands-on with VVols, we do have, Dell does have an entry in the VMware Hands-On Lab, 1674, I think, that does have VVols in it, along with compelling stretched metro clusters. So very, very useful to be able to get hands-on with the technology at an early date. So let's skip on. And so why should you care about VVols? I mean, technology companies, VMware, Dell, we all come out with these, ooh, new feature. You gotta, get with it. When VMware announced the licensing for this back in February, I was very surprised to see it at standard. And for me, it made a very clear statement from VMware that this is how we're going to do storage going forward. VMFS is great. It has its pluses and other things. But, we're going to go very strongly with VVols. So get to understand the technology. Scaling. So one of the limitations that VMware has had to deal with over the years is the 256 SCSI ID LUN limit. This has meant there's only so many volumes that you can present to your vSphere cluster. Okay, so I've got 255 volumes or so. That should be enough, and I'll make them bigger if I need to, because now we can make them up to 64 terabytes. But that comes with its own issues in terms of backing up that environment, or SCSI 2 reservations, which VAAI largely resolved. By going to VVols, that LUN limit goes away. You go from consuming up to 255 down to one PE as well, or one LUN consumed for PEs. And granularity. You'll hear me use the word granularity way too often during the session, because that's what VVols is all about. What previously used to be a LUN full of virtual machines is now a virtual machine consuming multiple volumes on the array. So whatever you want to do to that virtual machine, you can do it on the array, or have the array do the work for you, I think. So what is wrong with VMFS? I titled this slide nicer last year, but it's the idea behind VMFS is very good, very valid, and it's been great to us since VMware came out in 2003 or so. The issue, or the limitation with VMFS has often been what I can and cannot see. So as a storage admin, I give the vSphere admin a volume, and I know nothing more about it. He might be using it for Oracle, Exchange, VMware, that new cool product that he's talking about. I don't know what he's doing there. I can see the IOs as a storage admin that it's doing, but I don't really know. And then from a vSphere admin's point of view, I've had to manage a lot of things. I've had to balance, the consumption of that space, the IOs that are being worked on or created by that virtual machine. I've had to balance that out across volumes. And then things like replication and snapshots. I don't want to replicate every virtual machine that's on this volume, so I've got to move virtual machines around, because from time to time the replication needs of virtual machines change. A virtual machine that's running in production eventually becomes a less important virtual machine. It's still important, but in a DR scenario, it's the old version of the application. We don't need it straight away. So now you've got to move that around onto a different volume that isn't replicated as frequently. So no insight to the true space and performance consumption. Kind of touched on that, but really what it comes down to is who can see what. What the vSphere admin sees is going to be different from what the storage admin sees. So there's that conflict of, well, it's working fine for me. I don't know what your problem is. A lot of finger pointing that goes on. So VVols resolves that by everybody seeing the same metrics and the same data. So troubleshooting now becomes a much easier problem to resolve. All data services at the volume, and we're talking about how, again, the replication snapshots, we look at volumes, not at virtual machines, which is fine for the storage admin, but it doesn't do the vSphere admin any good. We've always had slack space on a VMFS volume. This goes away with VVols, so you're getting more efficient use of your storage. You have that slack space for using virtual machine volumes because you're using thin provision VMDKs, various different reasons. But again, waste of space, waste of time, waste of storage. Excuse me. So how does VVols fix this? In a nutshell, we've gotten rid of that volume and we've replaced it with lots more volumes. But what we took away was a volume full of virtual machines, and we replaced it with a virtual machine which is made up of a group of volumes. So we'll dig into that deeper, and by the end of the session, I hope you understand what exactly I mean by that. So volumes are gone. VMFS is gone, mostly. There's a little bit of VMS still there. From a storage admin's point of view, you, depending on your storage vendor's implementation, as you see later on in some of the EqualLogic screenshots that we'll show, it's going to show you what virtual machine is consuming what VVols, how much space they're consuming. Using our SAN headquarters tools, you'll see the metrics that those are producing. So you get a huge amount of detail about that individual virtual machine that's causing a problem in the environment. You have the option to do per virtual machine data protection policies. Now, that's nothing new, just that the way that it's been implemented in the past has been more of a shim, and it works fine, but it's not as efficient. This will result, these changes for VVols will result in a lot less space being consumed and wasted on your SAN. Most important thing, all this is done from Virtual Center in terms of your management of VVols. So you as a vSphere admin don't need to become half a storage admin. You're going to stay in your same vSphere environment, the wonderful single pane of glass. We all hate that term, but we have to use it. It's going to be that central management point. If you go through the hands-on lab that we do have, there's a section in there that talks about workflows and how they've not changed. And it shows some very good examples of how you've always done it and how with VVols, even though VVols changes a whole lot of stuff, it hasn't changed the workflows. So hopefully easy and efficient from your point of view. So there's lots of different parts to the VVols environment, but the part I want you to focus on is your virtual machine up the top here, same as it's always been in your vSphere server, vSphere environment. You still got your hosts, they haven't changed. There's this thing called protocol endpoint. We'll get into that in more detail, and we'll talk about storage containers. But the bit I want you to focus on here is this concept of we've got VMX, a VMDK, a vSwap. Those are all familiar terms. What I want you to see or visualize there, these individual, would look like barrels, they're meant to be volumes. These individual volumes make up a virtual machine. So from a storage point of view, when you want us to do something, we do it on the entire volume. Now that a virtual machine is a group of volumes, we can do things for that virtual machine that previously we couldn't do, because previously we just saw a single volume and we had no idea what was inside it. So this fundamental, that change of a virtual machine being part of a bigger group and on the SAN to becoming multiple parts on the SAN means that the SAN gets to manipulate or help perform tasks for vSphere. There's a lot of other terms there. We'll cover them, but I think that's the most important one that I want you to grasp. Okay, so those of you who already are familiar with VVols, you can take a 5-minute break, take a nap, because there's a whole lot of new terms that VVols introduces that I want to make sure that everybody has a reasonable level set on, and when I start using terms like protocol endpoint, storage container, that you're not kind of going, I have no idea what he's talking about. So the VASA provider is not a new term, but the VASA provider plays a very different role than it has in the past. In the past, the VASA provider was part of storage policy-based management, and it still is today, and it just told us the capabilities of an individual volume, and then if storage-driven profiles wanted to storage in motion that, whether it was a good idea to do so or not. With VVols, there's a whole load of communication that occurs between the virtual center and the array that doesn't, or currently today, can't go up and down the storage stack. So the VASA provider acts as an API translator in that sense. So when VMware wants to perform one of these tasks, it communicates to the VASA provider communicates down to the array over the management protocols for that array. This is each vendor provides their own VASA provider. In the case of Dell EqualLogic, it ships as part of our VSM plugin for Virtual Center that provides a whole host of other functionality, and we'll cover some of those later. So some of those out-of-band management commands are, whenever a virtual machine needs to be powered on, VSM performs that communication down to the array of bind that individual volume to the protocol endpoint, and then vSphere can power it on. The reason why it needs to be bound and unbound, at the end of the day, it comes down to resource communication and boring internal parts of any array and minimizing that so that you can have, at the end of the day, more virtual machines on that same resource. Protocol endpoint. So this is exactly what it sounds like. This is where the protocol ends. Very descriptive of what it actually does. Because in the overall environment, you have the ESXi host, you have your SAN, and at some point in time, the protocol, iSCSI, our fiber channel over Ethernet, ends at the SAN point. It doesn't go the entire way down to the virtual volume. It goes to the volume, but we haven't got volumes anymore. So the protocol endpoint is where all that ends. In the EqualLogic implementation, there's a single protocol endpoint, on ID 257. So the iSCSI connections are going to terminate there. So a side issue, those who are familiar with EqualLogic and how it scales out and use the multi-pathing plugin, I'm sure you've all hit that iSCSI connection count limit and kind of had to redesign your environment. With VVols, that iSCSI connection count drops dramatically because you've gone from having multiple volumes or multiple VMFS data stores down to having a single protocol endpoint. So that's going to dramatically drop your your iSCSI connection count consumption. The math is a little bit different, but that's a rough quick intro on it. So the access controls for the entire environment, because we don't want everybody accessing the VVols or the underlying virtual machines, are controlled at the protocol endpoint. That access control is managed by you from within the vSphere plugin. So you're not, again, being half a storage admin. You as the vSphere admin are going to control all of the VVol environment. So a storage container. Depending on what side you look at this, it's either the same or completely different. Excuse me. If you look at a storage container from the vSphere side of things, it looks like a data store. As far as you're concerned, you can browse it. It looks like a data store. It's going to have folders. You open those folders that represent individual virtual machines. You're going to see the virtual machines log files. It looks like a data store. It acts like a data store. It behaves like a data store. It's a very big data store because previously you were limited to 64 terabytes for a data store. With storage containers, they're limited, I think, to about 8 petabytes or some silly number like that. That when you run into that being a problem, it's going to be 5 years down the road and we're going to have other problems to deal with, and we'll just, change variable or something. It's one of those ones that's in there in the code, and it's kind of the, hopefully we don't get to Y2K for that. So you see that as a storage container, or as a a data store on the array, and it'll show up as a data store of type VVol. On the array, it's not a volume. It's not a data store. There's no VMFS. Probably the simplest way to think about it is that it's a folder object inside of which virtual machines are stored. We can get more complicated than that, and it's more entertaining, but essentially that is what it is. It's a folder object. Virtual machines are stored in there. The way it's been implemented on EqualLogic from a design perspective, EqualLogic tends to be very conservative. We say, okay, you're planning to use 5 terabytes for this project. We'll reserve 5 terabytes for you from the free pool space. Different array vendors, and even within Dell Storage, Compellent, I believe, are going to implement this somewhat differently. Again, that's subject to change. But we see, EqualLogic is very conservative in that fact, so we reserve that 5 terabytes that you think you're going to use. If you don't use it, that's fine. You can shrink the storage container, or you need more, you can increase it. So you have that flexibility in there to click around. I think so you can see some of the information that you as a storage admin are going to see from the array GUI. In terms of storage containers or space they consume. This is an entire new section of the GUI for EqualLogic, but there's some information provided there for the storage admin. This is where it gets a bit more interesting for the storage admin, because now he sees the names of your virtual machines, what operating systems are online, what operating systems they're using. The fact that you're now using Windows 10 in your environment, your storage admin is not going to know. He's kind of nosy like that. But you get a lot of, this is meaningless to a lot of us, but it means a particular virtual machine. But the piece here, this tells you a lot of information, or these are the different virtual VVols of this selected virtual machine. I've cut out some of the information there because I think that gives you a quick snapshot of, okay, a virtual machine now is, again, multiple volumes. There's different types of VVols. There's a config VVol that's a thick provisioned 4 gig volume. And this is where your VMX file lives. Other important files like log files and so on. This is where there's a little bit of VMFS in the environment. And that's what that contains. For every VMDK that's attached to a virtual machine, there's going to be a VVol on the array. So if you had a database virtual machine, you get the C drive for the OMS, you've got D and E for the different database drives, and you've got Q as the temp drive. That's what those are all going to be, 4 different VVols on that virtual machine. A swap file, we still have the need for a swap file in case you over-provision your memory. That's going to be also a thick provisioned volume on the array, where if you have that virtual machine consumes 8 gigs, it's going to have an 8 gig vSwap file created. If the reservation is changed, that will affect that. So it gets into the whole vSwap reservation math, which is pretty straightforward in terms of if you have a reservation, you don't need a vSwap file for that part of the reservation. If you take a snapshot of a virtual machine in VMware, you take a snapshot, that's no longer VMware's job. We'll cover that in a little bit more detail. It's going to create a snapshot volume on the SAN. If you elected to take a memory dump because you're interested in what the contents of that memory, of that virtual machine had in memory at the time of the snapshot, that's also going to create a VVol of type memory. And finally, if you're doing VDI, you'll have a digest VVol for the Horizon CBRC, content-based read caching that occurs, which is a very useful feature of a VDI. The only marketing slide I stole, and kind of salesy, but it really spoke to what needed to be covered here. That big array is a nice 5 view. It's the PS 6610. 84 drives, 6 terabytes, big honking amount of space. Nice performance numbers. Obviously that supports VVol, that just shipped in June. The requirements being firmware 8.0. But firmware 8.0 will also run on this long list of array models that we have. But short answer is anything you bought since 2009 should run VVols. So we like to think of investment protection. If you're using an array before 2009, talk to your sales guy. I'm sure he can work out some deal with you to get something. 6-year-old SANs are 6-year-old SANs. The fine print up the top is nothing important. It's the fine print because like, oh, there's little number 4. What do we mean by that little number 4? So granular storage policy-based management. This is the other part of VVols. This is the software-defined storage part of VVols. So when we had VASA 1.0, we had the capability of telling you, the vSphere admin, these are the capabilities of this volume. And we sent you up a string of information. We told you this volume was capable of RAID 5, it had replication enabled, it had snapshots enabled, but we as the storage guys could only send you a single string of information. So when you were creating a storage policy, you had to create a storage policy that reflected that single string of information. If we then later on disabled replication, your storage policies were no longer compatible because, well, you had replication in your storage profile because you had no choice. But you don't care about replication for all of your virtual machines, and it was a limitation of a single string of communication. With VASA 2.0, that string has now become multiple individual capabilities. So we tell you that this volume or this storage container is capable of these various separate individual features. You, the vSphere admin, then go create a storage policy. You can create a storage policy that consists of multiple vendors, VASA 2 providers. So you could create a storage policy that says, it must be RAID 10. Okay, and you go and you create a storage policy that you have capabilities of your different storage, from your different storage vendors, that when you go to create a virtual machine, you select that storage policy, it filters out all the storage containers that are of type RAID 10, and you apply it to that virtual machine. Excuse me. But storage policies are a lot more than that. Think of the life cycle of a virtual machine. The life cycle of a virtual machine is such that in the beginning, it's not very important. We've cloned out or deployed from template a virtual machine with the existing OS. Now we're going to apply all the hot fixes that came out, update the antivirus software, install the application, whatever. These are all non-critical parts of a virtual machine. We need them for the future of the virtual machine, but if the virtual machine blew up, it hasn't got any production data on it, so we're okay. So the storage policy that we might apply to this virtual machine is, put it on any storage that's available, I really don't care. Then, we get to staging the environment, so we change the storage profile to be, let's put it on storage let's assign it a storage profile that is similar to production, but is not production. So maybe it has the same performance as production, but it's not replicated. So we change the storage profile. As it moves on through its life cycle, it gets on to more important, and then eventually at the other end, it goes back to being, this is the old version of the application, it's important. We need it at Dior, but it's okay if it's a week old at Dior because it's not that important. But we still need to have this virtual machine live around. Oh, and now because of governmental changes, it has to be on encrypted disk as well. So that's what storage policy-based management is in a nutshell. You get to create this capability, this policy, you apply it to the virtual machine, and then it watches the storage for you. So when your storage admin is getting tight on space and he changes the underlying RAID policy on you from RAID 10 to RAID 6 because, well, he can't buy any more storage and he's hoping nobody will notice, Virtual Center is going to tell you that your virtual machines are no longer on RAID 10 storage for some reason. Something's changed. It's gone to RAID 6. Or maybe he didn't re-up the license for replication. Now, EqualLogic is an all-inclusive licensing policy, but with other storage, that's not necessarily the case. So it monitors that for you. My apologies. So that's storage policy-based management, very flexibility. And it's, again, that software-defined part of it. You as the vSphere admin, you select what's important to you. Okay, so some of the other benefits that VVols brings to the environment. Remember I mentioned how the virtual machine is now just a bunch of volumes on the array. When you go to deploy a virtual machine from template, vSphere is not going to do any work. vSphere is going to say, hey, EqualLogic, can you give me another copy of these volumes? On our end, we create a whole new set of pointers. Those pointers are going to point back to the same blocks of data as the template, and we're going to return those pointers back to VMware and say, okay, here's your virtual machine. And VMware's happy. It's going to power on that virtual machine, and you're happy because you got that virtual machine in about 5 seconds. Well, maybe you're not happy because you used to be able to get up and go have a cup of coffee while the virtual machine deployed. Legal kind of get all fussy about numbers, so hence the bar graphs. But as you can see, legacy took a long time. VAAI significantly helps that. VVol reduces it down to about 5 seconds. It's going to depend on your storage. That's what we see, what I've seen in our environment. If you take the hands-on lab, you won't see 5 seconds because that's using a whole load of fake stuff. But it takes about 9 or 10 seconds, which is pretty good in a virtualized environment. But this comes down to the virtual machine no longer being part of a volume, but being a group of volumes by itself. Let the SAN do the work that the SAN is much more capable of doing. Again, let the SAN do the work that the SAN is more capable of doing. So VMware has had snapshots as part of their virtual machine technology for a long time. And if you read their KB article on best practices for using snapshots, it kind of says, yeah, you can do 30 of them, but only do 2 or 3 deep snapshots. And don't hold them open for too long because, well, it kind of gets in, slow and things like that. So VMware is cautious in, saying, yes, we have snapshots, but you kind of don't want to use them or, use them within limited circumstances. Hey, apply a hotfix. Didn't blow up the virtual machine? Great. Unapply the snapshot. For SANs, it's a crucial part of SANs. Storage vendors have always had snapshots, and any of the new storage vendors that come out, they'll have snapshots as a day 0 functionality. Snapshots are done very differently when it comes to storage than the way VMware is doing it. You had these Delta logs, and when you were reading and writing, different files got changed, and when you eventually had to consolidate those back, it was very slowly done. With EqualLogic and Compellant, it's done with a whole lot of pointer manipulation. We could probably spend half an hour talking about snapshots, so I'm trying to give you a quick 30-second version of it. But basically, if you look at the, let me get the laser pointer. Basically, if you look at the graph, or the picture, our original chunk of data, we then changed the pointer because we took a snapshot, and after the snapshot, we wrote to C1. And then we took a snapshot, and after the snapshot, we wrote to the C block, and that became C2, and we also wrote to the E block, and that became E1. So what we're doing there is we're not moving data. We go, we grab a new block, or in Dell and EqualLogic, we call it a page. We say, okay, we're going to grab a page for you, and now you can do the writes in there, and we backfill that page with the other data that belonged there. But when we want to roll back a snapshot, we're just looking at a different set of pointers to present back to you. So there's no copying or moving or manipulation of data. It's just a whole lot of pointers. Pointers are little bits in databases. They're 0 size essentially. So that lets us have those snapshots exist forever, or as long as you got storage. VMware limits the number of snapshots that a virtual machine can have to 31 or so. And I'm hoping that's something that changes going forward. There's no reason why it can't. And then when you go to do a restore, it's going to be instant, because all we're doing is unmounting the current volume, mounting the snapshot, powering it back on, and you're good. So snapshots as part of VVols can become part of your backup story. They're not backups, but they are part of your data protection story in terms of, hey, this is a very important virtual machine. I'd like to snapshot it every hour, So I only have to go back an hour if it blows up. But your nightly incrementals and your weekly bitfuls, you still want to do. So SAN Headquarters, part of the EqualLogic feature suite. This is our SAN monitoring tool. Because of virtual machines, a bunch of VVols, sorry for saying that for the 15th time, you get all the SAN Headquarters metrics. So SAN Headquarters will tell you all the IOPS that has done. And down the bottom here, you probably can't read here, but these are individual VMDK VVols. So we know that the VVol 08, we know that it was doing 2.5 megabytes per second at that point in time, which was back in May sometime, but that's what it was doing. So you get that level of granularity for, at May 28th at 1708, it was doing 2.5 megabytes of throughput. So you get that level of data today. And in the future, our vRealize plugin will also have that data. So from your single pane of glass, you'll have that info. So that should means that when the DBA starts complaining that their virtual machine is slow, at least you and the storage admin can agree that, well, it's not the storage, it's not the vSphere environment, it must be something else. Your mileage will vary. So a couple of years ago when I first saw the VVol spec and how we were going to do it, I cringed. I had all my hosts, all the I/O from them coming into a single protocol endpoint. And it's kind of like, performance is going to go down somewhere. And that was kind of like, as a vSphere guy, I was kind of like, yeah, I didn't like that part of it. So these numbers, 70K random read write, as you can see in all cases, whether it was 4K block size, 16K or 32, there was somewhat of an improvement. I'm trying to figure out, and I need to, this is why these are not legal numbers, these are, your mileage will vary, why there's such a difference for the 16K block size. So I need to sit down with more of my performance guys to understand why this differs. But from a design perspective, even though all the I/O is going through a single protocol endpoint, it is not slowing down your environment. So VVol best practices. Deploy VSM, which is the VASA provider, which is now a very important part of your VVol environment, because the VASA provider is involved of, when you want to power on a virtual machine, the VASA provider gets involved. When you want to power off a virtual machine, the VASA provider gets involved. So if you lose the VASA provider, so I have a host, it's running as a virtual machine on an ESXi host, if somebody goes and yanks the power on that, I've now lost the VASA provider. This means at this moment in time, I cannot power on a virtual machine. That's okay. Typically I'm not powering on and off virtual machines. vSphere HA will kick in, power on that virtual machine on another volume, on another ESX host. This is why it needs to be on a HA cluster. This is why it needs to be on shared storage. Do not migrate the VSM to a storage container. This gets you into a very ugly chicken and egg scenario where you have no chickens and no eggs. VSM can be protected. It's in the documentation. It's in the tech reports. There's a database that's on it. Back that database up. You can access a CIFS share on it to pull off that database. So if somebody deleted VSM, because nobody's ever done that, you can at least redeploy VSM, copy back in the database, and get back your history of that virtual machine. You no longer need to over-provision your storage. To increase the size of a storage container is a couple of clicks, and a couple by 3 or 4, I didn't count, but it's a non-problematic task. It's not a task that you have to say, okay, let's get up on Saturday at 2 o'clock in the morning and do it then because it's somewhat disruptive. It's not. It's, again, just a volume folder that we're going to make a little bit bigger. So don't worry about that. Be careful when tweaking disk max LUN. So this is one of those values that VMware has that you can tweak. It's wonderful. If you have 20 volumes in your environment, when VMware does a scan of do you have new volumes, VMware is going to count all the way up to 255. So in some cases, people have tweaked that number down. If you tweak it down and you try to apply VVols, you're now no longer going to find that protocol endpoint because, well, it doesn't exist. Or at least that's because the LUN ID doesn't exist. Know the limits. So VVols is new. Our firmware is new. Our firmware is changing. VMware is changing. Patches and updates to both those can change limits. So know those limits. And keep an eye on the release notes if you have it in or if you're interested in how these might change. So the ones that won't change, a virtual machine counts as 3 VVols. Snapshots, when you snapshot a virtual machine, it's going to snapshot all of those volumes. So if I keep a history of 30 snapshots for that virtual machine, that's going to be 90 snapshots. If I include a memory dump, that's going to be 120 snapshots. Now, SANs do big numbers of snapshots, so that's not a problem. When you've got a small number of virtual machines, you get a large number of virtual machines, you've got to keep an eye on that as well. For a VDI environment, it's going to be 4 VVols for a base virtual machine because constant content-based read caching has that digest VVol. The reason I mention this, EqualLogic is limited to 1,024 VVols. I think I call this in the limitations. 1,024 volumes. So a VVol counts as 3. So in the current EqualLogic implementation, you're going to be limited to about 300 virtual machines. Okay? That will change in a future Dell Storage firmware release. When? Don't know. So there's no numbers on the slide for a very good reason because these are changing. VMware has a KB article that goes into detail on what VVols doesn't work with today in their suite. That's the KB article number. That KB article might be changed by the end of the week. This is VMworld after all, when VMware comes out and tells us, hey, we've got this new feature. Probably the biggest one that when customers talk to me about VVols is, when are you going to have replication? The answer to that is in the future Dell Storage firmware release. But that is one of the features that you'll see VMware not having support of for a lot. Obviously, they're going to add support for that at some point in time. Not my place to tell you. For EqualLogic, see the firmware release notes, see the VSM release notes. Again, no SRM support. We did look at doing replication through the back door. Those of you who use the VSM tool know that it has this SRM light functionality where it will register and or present the volumes and register the virtual machines for you at the DR site. We did look at doing that. I think the shorter answer on that is it was not pretty. So we stepped back from doing that. There are some limitations on scaling. One of the ones that has changed from firmware 8.01 to 8.3 to 8.03 to 8.04 is the number of members you can have in a group. We've limited initially you to 1. That grew to 3. That's going to change again. So hence no numbers on the slides. Compellent support coming in the first half of next year. I expect it to be closer to the end of first half than to the earlier part of first half, but that is not something that we're ignoring at Dell Storage. Compellent will have VVols. So we're running a little bit tight on time because I speak a little bit long, but some early customer feedback from some of our customers. Liking VVols, liking how we've implemented certain features, enjoying our lab. We're definitely not going to have time for a demo. So, excuse me, I'm trying to avoid coughing. If you are curious about VVols, whether it's VVols in general or EqualLogic's implementation of VVols, go take the hands-on lab. It'll give you a good detail on how we've done it. Don't feel you have to do the hands-on lab today because it is going to be available online from about late October. VMware publishes them. So, okay, up to you. Thank you.
All right. Thank you, David. All right, so my name is Jon Biggs, and I'm a senior infrastructure engineer for a company called George Jon Associates. We're based out of Chicago. So who are we? Well, we're a managed service provider and a very value-added reseller, and we have 8 years experience in the e-discovery industry. We're a Dell partner. We're also partners with Relativity, iPro, Nuix, and recently LexisNexis. We deploy a scalable solution that's architected all on Dell as much as we can, so we use EqualLogic or Compellent. We try to use all of Dell products for backup and everything else. We use all Dell Power Edges and whatnot. I'm going to skip along to the next one. So David's asked us to come and kind of talk about how we are leveraging virtual volumes in our current environment and how it's going to help us or some of the pain points we're having. And the first big one for us is going to be these new protocol versus the iSCSI connections. And I'll go into a little more detail here on this. So this is kind of a medium-sized environment for us. We might have 8 ESXi hosts, 3 EqualLogic volume members with in a storage pool, and we've got 16 volumes of data files, 15 terabyte volumes. So in the current world, you have 2 connections per volume slice to each member in the storage pool. And with 8 ESXi hosts, 16 volumes, that amounts to 768 iSCSI connections to that storage pool. And why that's important is each storage pool has a 1,024 connection limit. So when we're architecting these solutions for our clients, if we grow much larger than this, we now have to implement a second storage pool. We have to implement second VM clusters to grow beyond this. So protocol endpoints is going to change all that. I've kind of simplified this on the slide. I say 2 protocol endpoints per member. It's actually, you get 1 connection per VMK, iSCSI VM kernel on your storage HBA per member. So say I've got 2 10 gigabit VM kernels in this sample for my iSCSI environment. So I get 2 connections per member, and then for 86i hosts, that's 48 connections total. And that doesn't matter how many storage containers I have, how many virtual machines I have, how many VVol disks I create. That's no extra impact on the iSCSI connection count. And that's huge for us because now we can grow these environments much larger. We can have more ESXi hosts, we can have more storage pools, we can add more members to a single storage pool if we want to. So that's huge for us. And I don't know if any of you have ever run into that limitation, but that's huge. So the next thing that we're leveraging virtual volumes for is the VVol cloning, fast cloning. So one of our partners is Kcura Relativity, and they are an e-discovery platform that's used by law firms, government agencies, and corporations for litigation support, internal and external investigations, matter workflow, information governance, and whatnot. And their challenge right now in their databases are the SQL full text indexes. So as their full text indexes get really large, queries start to slow down. If we have to rebuild the full text index on a 10 terabyte database, that's going to have to be done overnight, and it's going to take hours and hours to complete, and that'll affect performance of the SQL instance. So their solution is to deploy Elasticsearch, which is a big data solution. It's a NoSQL solution. It comes with multiple nodes. It's got a master node, client access nodes, monitoring nodes, and then data nodes where they store the index shards for that data. So as demand increases for queries, and we need to speed up our queries and searches on the data, we can leverage the virtual volume cloning to clone out new data nodes in 5 seconds and get those up and going. And whether we use the big data extensions or the automation products, that still leverages down to the VVol cloning level. Shrinking volumes is going to be big for us. So the use case for shrinking volumes is things that are short-lived, that get deleted at the OS level, but they're still consuming space at the stand level. Things like SQL temp databases or file servers. In our industry, the companies will ingest data from multiple clients, and then they process through this data with a program like Nuix or LexisNexis Law. and then they import that into the relativity database for review, and they move the files from one location to their permanent storage location. So now the origin location, we've deleted all the files, but they're still sitting on the SAN. They're just unmapped. So vSphere 6 has introduced unmapping directly at the guest OS level, support for that. So that's supported today now in vSphere 6 at the VMFS data store, and it's supported at virtual volumes. So when a file gets deleted at the OS level, it passes the commands down the storage stack, and it gets deleted from the SAN level. A pain point is we're not there yet with Dell Storage for virtual volumes, but they are planning to implement that feature in the future for us. So right now, George Jon does not use thin volumes, thin provisioning at all. So we can't take advantage of the unmap yet. The reason we do this is for less management overhead on storage management. So having to manage all the clients and all the different thin provision volumes is just too much overhead. So we statically assign storage from the get-go. But that limits us in shrinking the volumes, because currently we can't just quickly shrink a volume. In EqualLogic, you've got to take a volume offline to shrink it, and clients don't like downtime. So what we do is we use a block level replication program. We create a new volume that's a smaller size, we block level replicate it, and then we wait until the middle of the night when no one's making any connections, and we quickly flip the shares, do it really quickly, and delete it. So that's how we solve that. But now with virtual volumes, we're actually looking to be able to implement thin provisioning, because virtual volumes are thin provisioned by definition. So when you create the storage container and we deploy our VMDKs into this, they're thin provisioned. We still reserve the amount of space like we would now on the SAN. So it's the same management principle, but everything is thin provisioned under the hood. And then once Dell is there with their support, the shrinking will be automatic. You no longer have to worry about having to schedule shrinks or do all of our block level replication anymore. All right, and the last use case here is snapshots and backups in the big data world. So in big data, and our stuff is big data, but it's not the same way as big data as Hadoop. It's still millions of tiny files that are discovered and processed. And the challenge with that is that there's just too much file metadata for traditional backup software to handle. It just chokes on it. So what we found in the beginning, in our first few years of being in the discovery industry, software like Backup Exec or NetBackup, if you're trying to back up 100 terabytes of data, it took weeks to get that initial backup into play. And companies didn't want to be out of compliance with backups for weeks. If we used Veeam or vRanger to back up our virtual file servers, they would take a snapshot and start backing up. And while it's backing up and taking so long, the deltas would grow to the point where they would fill up the whole VMFS data store and crash it. And then our virtual machines would go down, the clients would be unhappy. So we did two things to get around that. First, we brought in Aperture, which is a Dell product, and that does block level backups. So now we back up all of our data. Instead of using Backup Exec, we use Aperture, which does a block level backup of all of our data, 100 terabytes in a week. We're protected, and then it's continuous backup protection. Like every 5, 10, 15 minutes, we replicate or we send changed files to the backup engine, and it's just a continuous backup. So there's no backup windows anymore. Another thing we did is we implemented using physical RDMs for all of our file shares. We did this because in the VMworld you can't snapshot a physical RDM. So that meant that when we created backup sets in Veeam or vRanger, it didn't matter if the client went and did it or one of our junior engineers did it. They couldn't accidentally set a file volume to be backed up this way, so it wouldn't do the snapshot and fill up the drive automatically. In this environment, we achieve our DR right now with VSM replication at the array level, and then we use SRM to bring everything up on the other remote side. So that's how we do it now, and virtual volumes is going to change that when we can get back into doing thin provisioned and using VMDKs for our file shares. So what do we hope to see in the future with virtual volumes? Well, we're hoping that maybe they can implement better granularity of off-host backups with the virtual volume snapshots. It would be great if we could take a snapshot at the array level and mount it to a host like we do now with the VMDKs and back those up instead. And we're looking for that to be coming, hopefully, in the future. That'll be non-disruptive. Another thing we really need is that full SRM integration, because right now we don't have it. So when we go into virtual volumes with our DR, we can still replicate with the EqualLogic, but we're going to have to script everything to bring it back online now. And SRM would be great to have going forward. And let's see, and what was the last granular replication option?
So that was down to, so the granular replication option would be, can I have one mic? The granular replication option would be where, so great with VVols, or in the future, with VVol replication, I have gone from replicating an entire volume of virtual machines, and VVols gives me the ability, when it's implemented, to replicate an individual virtual machine. Great, wonderful step forward. Now that you've given me that, I want a little bit more, because we're all like that. We all say, ooh, we could have this. So what if there's that Q drive that has that temp DB that is constantly churning data that is only of interest for about 30 seconds? I do not want that out at DR. I do not want to consume my replication pipe with that. So when I go to set up my SRM replication plan or DR plan, never replicate the Q drive is the type of thing. I want that object out there, but don't replicate the data that's on it, because the blocks are constantly changing and I don't care about them, and they're just going to cost me bandwidth. So that was the wish list. So
yep.
I think we're almost done. There's a couple of other sessions that I definitely recommend attending. There's 2 hands-on labs, or one from ourselves, Dell. There's a number of other from some of our storage competitors that cover VVols. Do take them. There's a tech panel on Wednesday. NetApp, HP, Hitachi, Dell, IBM, EMC, all up on stage with boxing gloves or something. That promises to be, I expect that to be a lively session, because 6 storage vendors on one stage, it can't be anything but fun. So definitely attend some of those sessions. So, down the very bottom, any future Dell collateral, questions, Dell.com virtual volumes, or you can hit me up on Twitter, D_Glynn. Okay, questions, head up to the mic, and we've got about 5 minutes for questions, but once we get kicked out, we'll go outside and keep on talking until people have questions. Thank you.
The protocol endpoints,
yep.
That's a virtual machine running?
No. So the protocol endpoint is a LUN on the array.
Okay.
It's a LUN of size about, in our case, 0, might be different for some other people. Think of it as a multiplexer. So all your connections from your hosts are going to come into that protocol endpoint, and then behind that you're going to fan out and connect to all the virtual volumes.
Okay, but that lives on each array. So if I have, let's say, 4 arrays and I don't have them in a group?
So if you have 4 separate EqualLogics, separate instances, you're going to have 4 protocol endpoints.
You mentioned 2 PEs per group. How do you achieve multiple PEs?
So where he was going with that was the number of iSCSI connections to the protocol endpoint. So there's going to be 2 iSCSI, assuming you're using multipathing.
Oh, I see what you mean. It's 1 PE, but 2.
Yeah, 1 PE. Okay. There's going to be 2 iSCSI connections to every protocol endpoint, every member in the group that protocol endpoint is on. Right. The protocol endpoint is going to be on all. So if you've got 8 members in that group, you're going to have 16 connections to that protocol endpoint from each host.
And then one last thing on the VASA, the endpoint That is a VM that's running.
The
And you
VASA,
were-
yeah, the VASA
you-
provider
you-
is.
You were talking about high availability. Are you guys going to do anything where we could run 2 of them in an environment? Because I could see a world where, let's say, you have an event on a server that happens to have the VASA, appliance as well as 30 VMs, and they all go down simultaneously.
Yep.
Now all of a sudden you have this problem where none of the other VMs can power up until the VASA is
So
powered up.
let's take that worst case scenario. I've got 30 host goes down. I lose 30 virtual machines, including my VASA provider. You get to set preferences and importance in terms of this virtual machine is more important than other virtual machines. But let's say everybody's equal because it's Orwellian. HA is going to try to power on the virtual machine. It's a VVol backed virtual machine. It's going to fail. It's going to move on to the next one. It's going to try. Eventually, it's going to get to the VSM one, or
Which
the
is on
VASA
the
one.
data store.
Power it back up. Now VVols is available. HA keeps on trying. I want to say the default timeout is 30 minutes.
Okay.
So hopefully, A, you get that, HA kicks in, B, brings VSM back on, VASA back on within 30 minutes,
Right.
and your virtual machines can start coming on. That's why it's important to have HA configured and on a HA cluster, and not for you to get up at 2 o'clock in the morning and
Right.
start doing this.
And that you put that on a data store and not on a VVol.
Yes.
What is how's the industry, the backup industry, responding, like Veeam or Unitrends, where they're doing VMware-based snapshots?
So I can't talk about, I don't know about Veeam, obviously. So Dell Storage has several backup products. They are using EqualLogic's VVol today in their development environment and working with us. I expect to see them go down to the Dell Storage booth because I know there's an announcement going on this week. But I can't tell you it because that's their stuff. But they're not ignoring VVol. We do see, as a company, Dell sees VVol as being very important. I, as a storage guy, hope that they take advantage of what VVols has the potential to do either now or as it evolves over the next 2 years into those backup products, and not just makes them VVol compatible, but says, okay, what new stuff can we do?
Do you see them, do you hear anything about them handing the backup off to the SAN, like we had talked in the...
So that's a capability we have today with, for example, net backup. If I have a regular volume, so let's say it's just a Windows volume, it could be a Windows virtual machine with an iSCSI within the guest mounted volume. I can have net backup, talk to the EqualLogic array, take a snapshot, and then leave that production machine alone. So my production machine is happily doing what it's meant to be doing. The backup has finished. It took a couple of seconds as far as I was aware, and it was a little annoying for a couple of seconds. Then the off-host backup server kicks in and starts backing it out. I don't know if Dell Storage is working on that, Dell Software is working on that today. Silos, like any company. I don't know if other storage backup vendors are. I, as a VMware guy, I, as a storage guy, see this would be cool if you do that. You really should.
If they want to make money, that'd be a good idea.
So it's a wish list, and I think you as customers have to go to your storage backup provider or your backup software provider and say, hey, VVols is coming. I'm going to be implementing VVols because of the following reasons. I expect your backup software to support it. To go a step further and make use of what VVols has the potential to do. Make my life easier. I'll continue buying your software.
Two quick ones. The VASA and the VSM, the VASA provided VSM, those are two separate VMs?
No. So the VASA provider lives on the VSM virtual machine.
Okay. On the VSM, you mentioned the database, backing it up, that kind of stuff. What kind of data is in that is critical that we want to keep?
So you don't get to choose what you back up out of that database,
Sure.
but it's the history of the snapshots, the configuration of the VSM. So bits and pieces like that. If you didn't have that knowledge, a lot of that, I want to say, a lot of the existence of virtual machines, for example, and therefore the existence of storage containers and so on, that can be rebuilt.
Yeah.
But depending on the size of your environment, it can
Maybe
take a while
monumental,
because there's a huge number of objects to be indexed. So if you have a maxed out environment and you go to deploy VSM and VASA today, it's going to take a while for it to pull in all the data about all your different virtual machines and all your different configurations. So it's a straightforward step to do. It's covered, I know, in the tech report. I used to know the number. But if you can't find that information, shoot me an email.
Sure. The question is, say we lose that, is that a disastrous event? Or is that we've got something, we got a challenge that we got to get across, or are those machines just not
So if somebody goes in
Yeah.
and deletes that VSM,
Sure.
now you've got no VASA provider, so you can't power on any virtual machines. So
Yeah.
now you've got an annoying problem, and you've probably fired somebody.
Sure.
You've no way of recovering that virtual machine for whatever reason. You're not backing up the entire virtual machine.
Yeah.
So you deploy a new one, you give the same IP, same host name,
Yeah.
same everything, and then you restore back in that database.
Yeah.
I want to say that it's simply as a case of copying that back into vSphere and going into the console, and there's a couple of menus there of restore database.
Yeah. And without that database, if you don't have a backup of that, you don't have that, you're pretty much,
You're going to lose your snapshots,
that's about it.
your snapshot history. It's going to be able to rebuild the other data.
So you go rebuild the whole thing, no new data completely, you'll be able to start powering on VMs again
You will.
with some config.
I think the answer or the question you're asking is, if I just install VSM, don't do a backup, don't do a restore of the database.
Correct.
Can I, or how long is it going to take me to be able to power on, power off virtual machines again?
Get back operational.
I don't have an answer for you.
Okay.
But if you shoot me an email, I can get an answer for you.
All right.
Okay, but the answer is going to be, it depends on how big your environment is. But I think you have an idea of, how long, you want an answer on how long that might be. You look familiar.
Well, unless you've been up to Minnesota, I don't know if we've actually met. But my question was, I saw you had a pane from the EqualLogic window that you could actually see like the VMX and other files like that. If the vSphere admin and the SAN admins are different people, can the SAN admin actually like read and download those files?
No.
Okay.
So
it just knows that they're there and can see them.
He knows what you've named your virtual machine. He
Okay.
cannot copy that virtual machine off
Okay.
and access that data.
Good.
Now, in any environment, there is always, if I have physical access to something, I can do something malicious.
Yes. No, I had some people be worried that they're saying admin.
Yeah, so
like,
you're
I can read the blocks or whatever. No. So no.
The answer is yes if he works with the NSA.
Yeah, exactly.
But the storage admin, he gets to know more about your environment. He doesn't get to manipulate your environment. So the storage admin, for example, cannot initiate a snapshot of a virtual machine, cannot power on a virtual machine. He can see your virtual machine. And in the description box, which is not currently implemented, but the description box is also a field there. So if you write, my storage admin is not a nice guy,
Yeah.
he's going to know that you said that about him.
Gotcha. Okay.
Okay?
Thank you.